So polyatomic ions, let's take a look in our packet at how to write a formula for a polyatomic compound. Okay, sodium chromate. This is an ionic compound, and remember with ionic compounds, we're almost always drawing Lewis dot structures. So I'll go ahead and put this in as an example in our notes here. And when we do a Lewis dot structure, we start with the sodium, and we probably remember from our periodic table that sodium here is in group 1, and on the back side, if you have the double-sided copy that I gave you, this is also available on Schoology, you can see that sodium gets a +1 charge because it's going to donate that 1 valence electron. So Na with 1 dot. Chromate, this is the brand new thing. Okay, you're not going to find chromate anywhere on the periodic table. It's not one of the nonmetals. It's a polyatomic ion, and polyatomic ions, you have to look them up. The naming isn't as rule-based as it is with the regular nonmetals over here. These all follow the same rules. The polyatomic ions, they don't all follow the same naming rules. So these are alphabetized. You can also find lists of these things on the web. So like here I searched for common polyatomic ions and got this thing with pictures, so that's kind of neat. And you can see that chromate is in here as well. And this kind of gets across the point I was making in the previous video, that a polyatomic ion is a big clump of many atoms. Chromate, for example, has a chromium atom bonded to 4 oxygen atoms. And that whole big clump, pictured here, has a -2 charge, right? This whole clump wants to accept 2 electrons. It will take 2 electrons to form. It acts like a single thing. Okay. Now you don't have to draw all this. This is a pain in the butt, right? If you want to draw this, all you really have to do is make some brackets, type in the formula, write in the formula, and here's chromate again, CrO4. And I'm going to put the charge on the outside. Okay. 2 negative means it's going to accept 2 electrons. So I can draw 1 from sodium there, and it wants 1 more. So I draw another sodium, and that's my Lewis dot structure. And now I have the formula. I've got 2 sodiums, Na2, and I've got 1 chromate, and 1 chromate is CrO4. This is not 4 chromates. This is 1 chromate. CrO4 is chromate, and this is the answer to that first one on the packet. Okay. I'm going to skip over to magnesium nitrate. This is another interesting example. I'll show you why in a second here. So example, magnesium nitrate. We know magnesium already is Mg. From our periodic table, we can see that it is in group 2, so it has 2 dots, 2 valence electrons. And then nitrate. Pay attention, it's not nitride, that's just N. Nitrate is different, it's up here in the polyatomic ions. Anytime you see something ending with ate with a T or ite with a T, that's going to be polyatomic automatically, and you should look up here. So nitrate here is NO3 minus. NO3, put it in brackets, with a negative charge. That means it wants to accept 1 electron because that's a -1 charge. So I can draw 1 arrow to that ion, and to get rid of this other one, I get to draw another nitrate. So this is really, it looks a little different, but it's really the same game that we've been playing all along with ionic compounds. Now here's something new. We've got 1 magnesium, and now we have 2 nitrates. But if I write NO3 and then put a 2 there, well, that doesn't look right. It says NO32 then, and that's no good. So what you do with a polyatomic is you put the whole thing in parentheses and then you put a 2 on the outside. So that's saying now I have 2 nitrate ions. And that's the formula for magnesium nitrate. One other thing I want to show you real quick. The pictures are great. I highly encourage you to do them, but there is still the charge shortcut method. Sodium is +1, chromate is 2-, and if you crisscross those two numbers, put the 1 on chromate and the 2 on sodium, then you get the formula. That's 2 sodiums right there. I put the 2 over to sodium. And CrO4, that's 1 chromate. Same thing with magnesium nitrate. Magnesium is 2+, nitrate is 1-. That means if I crisscross and put the 2 on nitrate, you can see that happened in the formula. There's 2 NO3s, and there was only 1 magnesium. So that's a nice short way to do it. In the next video, I'll show you how to do the names. They're even easier than the formula.